In this video, we will explain how to use the technique known as cross-validation voting. This technique allows training a single type of classifier in order to improve its generalization capability. There are classifiers that achieve a very high accuracy on training data, but they are not able to generalize and perform well on test data.
The recent development of deep neural networks allows solving highly complex computer vision classification problems. Often, although the results obtained with these classifiers are high, there are certain sectors that seek greater accuracy from these systems, such as agri-food and industry, or grocery product classification.
To achieve the high results that industry and other sectors require, we propose to review the training process that is usually followed with neural networks. Our objective was to demonstrate how this technique considerably improved the training of a single current classifier with respect to the results obtained by the other authors.
During the training of neural networks, we use a mechanism called early stopping, which allows stopping training when the validation behavior starts to deteriorate. This mechanism, commonly used, leads to a problem called validation overfitting. This problem occurs because the selected model is the one that performs best against the validation set used, but may not perform as well against other validation sets. The results are subsequently evaluated against a test set, independent of the training and validation data. However, because of the validation overfitting, it is possible that the results are not optimal. In our approach, which uses recent convolutional networks, we divide the training data into different validation slots, similar to how the cross-validation technique works. Next, we perform training of a single type neural network, such as ResNext, EfficientNet, or WideResNet. Each of the trainings uses early stopping with respect to its own slot of validation items. Finally, all models are integrated under a hard or soft voting model. Specifically, with soft voting, we have obtained the best results. The method can be integrated with classifiers of different nature, as long as they allow the early stopping technique. This integration allows the system to take advantage of the best of each classifier. Thanks to the loading of the models on the GPU and parallel inference, the integration of multiple models does not affect the processing in real-time applications. Additionally, we have explored the possibility of connecting different classification techniques directly to the features layer of the neural network, a layer prior to the final classification of these models. Using SVM, or boosting techniques with trees, such as XGBoost, LightGBM, CatBoost, or AdaBoost, the model can be integrated with these classifiers. This method requires prior training of each of the neural networks, in order to extract the feature vector. Subsequently, each of the SVM or boosting classifiers is trained with the features. During inference, the data is passed through the neural networks to extract the features, and these in turn are passed through the respective SVM or boosting classifiers.
After applying the described methods to the grocery product classification problem, we found that the cross-validation voting technique significantly improves the results obtained by all single classifiers, ResNext, EfficientNet, or WideResNet. Only with the results obtained with ResNext, we managed to outperform the best results obtained today by other authors.
The combination of three different networks with this technique further improved the results obtained on a well-known dataset of grocery products. Moreover, the training was fast since it was not necessary to use a large number of records. The use of SVM or boosting techniques performed slightly worse than with the neural networks itself, which allows us to confirm that this option, despite being used by other authors, is not necessary.
The presented method can be implemented in a simple way and allows improving considerably the results obtained by individual classifiers without the need to use models of different nature. In addition, we have seen how, if combined, they allow improving the results even more. These techniques can be applied in many fields that make use of artificial intelligence, such as industry, robotics, medicine, consumer goods, and so on. Thank you very much for your attention.